Okay, sorry about how short these videos are. My video camera has this tendency to cut off at about 15 or 16 minutes. So I guess that's just the way it's going to be till I get that figured out. So we're going to start with number 44, which says if dy dx is equal to sine x over x and y of 1 is equal to 4, then what is y of 2 equal to? So you're going to be able to put this in your calculator, all right? But what you do is you start out with the y value, okay, with something like this. So we have 4 plus, and then we're going from 1 to 2. X is equal to 1 to x is equal to 2. So we did not work this type in class, okay? So it's the answer at 1, which is 4, plus from 1 to 2 of sine x over x dx. This part you can just put in your calculator. So that's going to be 4 plus 0.659. So you would get 4.659, which is answer D. Okay, we'll work a few more that are kind of like that, where you can split things up and use the y and the x values to figure out how to do it. And then number 45. So this is the very last multiple choice question before we move on. So 45 says if f of x is a differentiable function with f of 1 is equal to -3 and f of 5 is equal to 4. Which of the following must be true? So what I like to do on these is let's just draw, we've had a few of these already, draw a graph when x is 1, y is -3. Okay? And then when x is 5, let's say that's over here, y is 4. So that's 5, and that's 1. And we can connect that however we want. I'm just going to connect it like with a straight, kind of a straight line. It says that it is differentiable. Okay, so part A, if you read through that, f of 0 is equal to k for some k between 1 and 5. Well, we don't know anything about f of 0. When x is 0, we have no earthly idea what's going on. So we don't have any information there, so that's not true. Part B says f of x is increasing on the interval 1 to 5. Well, it increases as a whole, but it could go, you don't know what happens, it could go down here before it goes up. All right, so that's certainly not always true. Part C says f prime of x is equal to 7 over 4. Well, that is the slope here, 7 over 4, change in y, which is 7, over change in x, which is 5. However, that's only the case if it's a straight line the entire way, that might be the way I drew it, but that's not necessarily the way this function is. So only if a straight line, which it doesn't tell us that's what it is. Right, part D says f prime of k is equal to 0 for some k 1 to 5. Well, that's not necessarily true. If it is a straight line, certainly the slope is not equal to 0, so that's a big no. So the only thing left is E. And E is the mean value theorem, which states for some place between 1 and 5, the slope of the tangent line has to equal the slope of the secant line. We know the slope of the secant line does equal to the change in y over x, which is 7 over 4. So somewhere in between the two, that does have to be true. That's the mean value theorem. So the answer is E. All right, so that does it for the calculator multiple choice. You can see that a whole lot of those you didn't really need a calculator. Alright, let's see if I can get, before this video conks out, one or two of the, probably just one, of the free response questions. So you can see here we have this kind of shape. The entire thing, the entire area bounded here is S. And that little part right there is R. And the area, it says the area of R is 3.712. And we do get to use a calculator for this section. So it says find, and this f of x is sine of x squared. Find the total area of S. Well, what I need to do really then is just, we know that this side is going to be the same as this side underneath. So I just need to find the area underneath there from 0 to where that crosses. Okay, and when I can get that, I can double this side. So all of this is symmetric. Okay, so let's go with, we're on AB3 and 1A. So the total area is equal to 2 times the area of R, so we'll say 2 times R, plus the area of sine of x squared. Alright, so, and the x-axis. Okay, so if you want to know where sine of x squared is equal to 0 right there, okay, you can just graph and trace that. Or you could use the 0 function on math, okay, graph it and do the upper bound and the lower bound each way. But if you do that, you'll find that it's 1.772. So we could go from 0 to 1.772 of sine x squared dx, and what you will get is about 0.9, right, for that. Okay, and so you know for that shape, so you've got that part, and all of that underneath, looks like a kind of a big heart. That part R. So this part is about 0.9 from your calculator. So you know that part's going to be about 0.9. This part, it says, is 3.712. So this part would be 3.712. And if you add all of that up, you get about 9.214. Okay, which is what you want to circle that. Okay, so that's really all you have to do is figure out that part, and then the rest of it is kind of logic. Okay, so that is part A. Part B, so I'm going to draw this thing again. Okay, it says set up but do not evaluate an expression for the volume of the solid generated when region S is revolved about the line y equals 2. So let's put that up there. We've got, let's see, can you see that? Alright, that'll be about 2. Okay. So you'll need to get an inner radius and an outer radius. So our, here's our, you can't see that probably very well. Need to get a new red one. Look at that, ready to go. Okay, so the outer radius is going to be the distance from 2 to g of x. Okay, so it's going to be 2 minus g of x. Right? So 2 minus g of x. Since g of x is below the x-axis, that's g of x. And the inner radius is going to be 2 minus, and this part is called f of x. So 2 minus f of x. Alright, so the volume is going to be from, so put the pi out there, negative 1.772, you had to figure that out last time, to positive 1.772 of the outer radius squared, so 2 minus g of x all squared, minus the inner radius all squared, 2 minus f of x all squared dx. And you don't have to put, you know, the sine equation and all that. You can just put f of x and g of x. So that's all they're looking for. You know, they want you to set it up like that, but you don't have to evaluate it. And it'd be impossible to evaluate because you don't know what g of x is. Alright, I'll give you just a second if you need to pause the video. Okay, let's work out part C, and we'll let that be it for this video. So it says that the region S is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is an isosceles right triangle with one leg in the xy plane. Set up but do not evaluate an expression for the volume of this solid. Okay, so what it's saying, we've done one of these with squares and I think rectangles, an isosceles right triangle. Okay, it's going to be the area is 1/2 base times height, but with an isosceles triangle, the base is equal to the height. So we can just say it's 1/2 times the height squared. All right, so height. All right, so the height in this particular case, okay, so for that whole thing, what's the height? If you were to chop this all up into isosceles right triangles, the height of that triangle is just f of x minus g of x. So our volume then would be, to sum up the areas, we've got that 1/2 out front, so 1/2, and then we're going from negative 1.772 to positive 1.772. Again, that's where they cross the x-axis of f of x minus g of x all squared dx. So the squared again comes from a height squared, so that's just the height of that triangle. And that half, we're summing up all the areas of those isosceles triangles. So that's free response question number 1.